All right, guys, welcome to Algebra 2. This is 2-2-2. So we're going to be, once again, taking a look at functions and how we can transform them, specifically looking at the left, right, and up, down shifts for each different family of functions. So to start off, we're going to take a look at the parent function x to the second. Okay, so one of the big things we've done is shown how this equation of this equation here, the x minus h, that causes a left-right shift of whatever h is, right? So if h is 3, it goes right 3. If h is -5, it goes left 5. Again, this minus in front is going to change the sign from what you would typically see it as, so just do keep that in mind. So our first thing is, well, why does that happen? So I kind of want to talk a bit about why that is happening, and I want to do that with Desmos. So I have here some tables. So here is the table of x to x to the second. Here is x to x minus 2. So what is going on, right? So here, let's say I plug in x is -2, right? When I plug it into the actual equation, I get -2 minus 2. I'm really plugging in the exact same thing as -4 on my original. So I get a 16 out of it, and lo and behold, I get a 16 out here. So what that's causing to have happen is my purple graph, right, is hitting the y values at -2 where they would be at -4 on my black one, which is 2 to the left. So my purple appears to be 2 to the right of the black value there, and that's going to happen for every single one of these. If I go to my purple value of -1, right? If I plug in a -1, that's the same as me plugging in a -3 up here, which gave me a 9, so I should get a 9 for -1, which is why I'm seeing here at 9 versus over here at 9. So this would move 2, this one move 2. All of them get moved over 2 because I'm hitting the same values as I would on the base parent function, but just 2 things later because of that -2 on it. So hopefully that kind of shows why you're getting that shift left and right from the -h portion of our graph. Okay, now let's head back to this and let's take a look at 103. So let's try and list out as many parent functions as we possibly can. So go and pause and try and list out however many types of functions you have seen in the past. Go. Okay, so ones you should have encountered, quadratics, that's parabolas, if you call them that, that's totally fine. Cubics, rationals are one of the ones we learned this year. Square roots, absolute values, exponentials. If you didn't get all of those, that's totally fine. Don't feel bad at all. But those are the kind of main ones we kind of expect you to know. We're leaving off linear because we already, those are really, really basic. They're almost too basic to really show what is going on here, but they do still work. But those 7, linear plus these 6, are the ones I would expect you to kind of know at least a decent amount about, because we've used them all a bit. So here's what we're going to do. I'm going to show you a kind of general what we would want to be doing here. So I normally would have a handout out for you, but this is what we're going to be looking at. So I want you to kind of do this kind of form for all 6 of those things we just gave you, right? We want the parent graph name, which I give you, parent graph equation, which I give you, and then an equation of a transformed function. So put in the a, the h, and the k. Where would all of those go, right? So for instance, on the first one, right, on the quadratic, I would have, let's leave this over here for right now. I would have a times in parentheses x minus h, close parentheses, to the second plus k, right? That would be my transformed function in graphing form. Okay, then give me a table of the parent graph. So go ahead and put it and plug in all of these into the parent function. Then sketch a graph of the parent function, and then pick some value for A, H, and K, and then sketch a transformed graph. I would pick like 2 or 3 or like 4. Don't go numbers bigger than that, just so that you can actually still see it on the actual graph here. And then talk about any interesting points. Are there any asymptotes on this graph? If so, where are they? Are there maximum points or minimum points? Where are those? Are there endpoints? Where are those? What are the important parts of that particular function? So you're going to want to kind of copy down this information for all 6 of those graphs. We're only going to do 3 today, and then I will have you do the other 3 next time, and then we're going to call it good. So again, you can pause it there, and then here is what I want you to do. So rest of your in-class time, go ahead and do that, and then tomorrow we're going to finish those off. So hopping back over here, that is going to be it for today. Just get those finished. And then here is our homework once that is done, 107 through 113, and I will talk to you guys next time.